Hi, I am going to be talking about polarization for the first part of this lab, and this is what you'll be working with. These are little devices called polarizers, and the way they work is light that we see from the sun or from other sources. Remember, light, as I talked about in lecture, is going to have electric fields that are varying in this way, and magnetic fields that are varying at right angles to the electric field. So the electric field could be vertical, magnetic field could be horizontal, or the electric field could be horizontal, magnetic field could be vertical, or it could be somewhere in between. And they're both oscillating, both the electric and magnetic fields, and the frequency at which they're oscillating corresponds to the color of the light. What these devices called polarizers do is they take the light that's coming at them, and they only let components of the light that have an electric field in a certain direction pass through. So in other words, if this is a line so that it'll only let vertical polarized light through, that stuff will come through, and the stuff that's polarized with the electric field this way will get blocked. So we often make sunglasses out of polarizers, and that because they reduce the glare, they reduce the amount of these other components of light that don't have the electric field in a given direction, so they reduce a significant proportion of the brightness that you experience. What's even more interesting about them is if you put two of them together, you can actually adjust the brightness. So you can have your camera have you can actually darken or lighten it by using two polarizers where one is rotated relative to the other. And you can see here that as I rotate it, it goes from being black or close to dark, fully dark, to something quite bright, where it's letting the light from behind it through. All right, so that's a polarizer. And what you're going to be doing is measuring the brightness of the light passing through it with the light sensor that you used in a previous lab and two polarizers hooked up in front of the light sensor where I rotate one of them relative to the other one, and you see how bright it is with the light sensor behind it. There's a little bit of error wrapped up in these measurements, but we'll just do the best we can. It's not very bright in my garage right now because I'm doing this rather late in the day, so that's going to be a source of error that will affect things. But you will see the alternating between brightness and darkness at the different angles, more or less as we'd expected, using what I will talk about in lecture, the law of Malus, M-A-L-U-S, where the brightness between two polarizers is determined to be the cosine squared of the angle between them, where the angle between them is 0 when it's at its brightest, and then it varies from there all the way around to 360 degrees, which is 0. So you go through a whole cycle there. And that's what you're going to see in your data. All right, on for measuring with the data now. Okay, I'm going to do my best to rotate the polarizing lens here. The top one I'm going to rotate. The behind one I'm going to keep constant position. You're going to see me rotate it. You're going to see it probably get lighter and darker with the camera that you're watching it with. And I'll do my best to rotate it in increments of, I'll tell you what the degrees are, and then I'll do an average each time. This is initially what we have, somewhere between 40 and 45 lux. I'm going to take an average, not where that dip is right here, but I'm going to stop it. I'll take an average over this region right here and avoid that dip. And if I do an analyze, statistics, the mean is about 43 lux. So go with, 44 lux. 44 lux. We'll take that to be the value of 0 degrees, 44 lux. I'm going to write it down myself. All right, now I'm going to rotate. I'm going to press collect. I'm going to rotate it. I can rotate it about 45 degrees. I think the lab says every 10 degrees. I'm going to go every 45 right now. I want you to see the general trend. Yes, I can be more precise if I have more time and more video space here, but I'm going to do something that will get you the data well enough that you'll be able to see what's going on. 45 degrees. I don't need to have that there, and let's see what it shows us. Get my hand out of there. And it looks like it's somewhere around, 12 or 13 lux. Let's see. to stop collecting to see it. And I will go with about 12.7. I'll go with 12.7 lux at 45 degrees. I'm going to go 90 degrees. I'll press collect. Notice on my hands here, it gets much lower, so I can't look at the data from one of my hands there. I have to move my hand away from it. Close to 90 degrees. All right, I'm going to give it a few seconds to equilibrate. Get rid of these if I can. There we go. Get rid of that one. I'll take a fresh new average in just a moment. It's a lot lower now. You can see the screen looks dark. Now the light sensor is getting stray light from behind the screen. There's a little bit of that happening. I can't really avoid that. But it's certainly a lot lower, and that's what we want to see. So I'm going to take an average over, let's see, not there, about right there. Analyze. Statistics. Stop it. Average is 4.6 lux at 90 degrees. Now I'm going to go to 135 degrees. A little brighter, you can tell that. Hopefully with the camera there. Okay. I'll let it do its thing here. Obviously it's moving back up into the brighter range. Okay, I'll get rid of this. Press stop. Analyze the data in here. Statistics, let me get rid of that little, statistics. Looks like it's 32.6 lux at 135 degrees. All right, I'm going to go to 180 here. Press collect. And I'll press stop. I'll analyze it right from here. Oh, started it again. Okay, just wait for that. It's going to be around 40 lux, it looks like. This should be close to the original value here. To the statistics. Looks like about 40 lux, 180 degrees. Okay, now I'm going to go another. Press collect. Maybe 45 degrees or so. Around 225 degrees. The brightness here. Statistics tells me it's at about 9.1 lux. Okay, 270. Let's collect. It's looking like around 4 lux. Let's stop it. I'm going to analyze. 4.5 lux at 270 degrees. Okay. Press collect again. Actually, there's something I want to do. I should have probably done this in the beginning. It would have made the graph a little easier to see. I'll make this, gosh, the most this goes is to 100. So I'll make this, rather than 600, I'll make it 50. Press collect. And I'm going to rotate this to 215 degrees. So. All right, 315 degrees. You can see it, the data collecting there. Looks like it's going to be around 35 lux. It's a pretty big uncertainty. You can see how much variability there's in the data there. It's varying somewhere between 34 and 37 lux, so there's definitely some uncertainty in the measurements. Okay, and let's see what I have here. Take the average of this here. Get rid of this other one. Looks like I'm about 35.4 lux at 315 degrees. 35.4 lux. And I'm going to go up to 360, which is where I started. Let's see what I'm at there. Right. Now it should be pretty close to my initial value, and what I'm seeing, my initial value is 44. This is looking more like, 38, 39. Looks a little lower than it had been at the beginning. So what's going on? Well, one thing is, the sun is going down. I'm in my garage, and there's less illumination coming in, so that is one source of error. So this isn't going to be perfect, but you'll at least get to see that the polarizer is varying at least somewhat how we would expect it to. So let me press collect just for this latter part here. Analyze, statistics, and I'm at about 38.6 lux. All right, so those are your data. What I want to do is plot those and see if they look something like what the law of Malus, M-A-L-U-S, which I will, there's a lecture on polarization, a short one, that tells me that the brightness from two polarizers, when one is rotated relative to another, like we're doing here, should follow something that looks like cosine squared of the angle between them. That's the law of Malus, M-A-L-U-S. And the data you show will show something like that. It's never negative, and it has basically two peaks, a peak at 0 degrees and a peak at 180 degrees. It looked like three peaks because 0, 180, and 360 are all going to be values that are pretty high here. Okay, so you have the data to work with that, and we'll next look at lenses.